Hello, welcome to the in-class review today. Uh, Now, each problem I would like you to pause it, or the substitute pause it, and have you go through the problem and then play the solution. All right, first I want you to multiply these values. Pause the video, and when you're ready, start it back up. All right, when we multiply these, we just FOIL it, so you have 15. The inside is going to be 10i. The outside is going to be minus 3i. And then finally we have negative 2i squared. That's not a very good 10. Looks worse. Huh. All right, let's try that again. 10i. All right, so now when I subtract these, I squared is negative 1, so that's like plus 2. And so I have 15 plus 2, and then these would be 10i minus 3i. So 17 plus 7i would be the correct answer. All right, simplify this complex number. Pause the video. Try to do it on your own. All right, hopefully you're done. Hopefully you remembered that you had to multiply by the conjugate. So 2 plus I. Let's try that again. 2 plus I. And when I multiply this bottom, 2 times 2 is 4. Negative 2i plus 2i cancels out. So then it's minus I squared. This top is going to be 15 times 2, which is 30, plus 15i. Now this denominator, 4 minus I squared minus a negative 1 is just like 4 plus 1, which is 5. Now when I divide this, this would be 6 plus 3i. All right, find the y-intercept of this one. Pause the video, see if you got the answer. Well, if I plug in a 0, 0 plus 0 plus 15 is 15. So my y-intercept is going to be at the point 0, 15. Find the factored form of this. Pause the video. All right, hopefully you're done with this. So this is x plus 5, x plus 3. Now find the x-intercepts of this. Hopefully you're done with this. So you set each of these equal to 0. So negative 3 and negative 5 are the x-intercepts. It says find the y value. Just find the vertex. So let's find the vertex. Pause the video, see if you can do it on your own, and then start up. Well, the vertex is at x equals negative b over 2a, which is negative 8 over 2 times 1, which is 2, or negative 4. And another way you could find that x value is it has to be in between the two x-intercepts. You could just take the average of those. Now once we have negative 4, we plug that back into this function. So f of negative 4 is going to be negative 4 squared plus 8 times negative 4 plus 15. Or 16 minus 32 plus 15. So that would be negative 16 plus 15, which would be negative 1. So our vertexes would be at negative 4, negative 1. Now let's just run through the whole system again. Find the y-intercept. Hopefully you pause the video and you got 0, negative 5. Find the factored form. Now instead of factored, maybe we should say intercept form, because this one you can't really factor. So we use the quadratic formula. Plus or minus b, no, negative b, plus or minus the square root of 3 squared, which is 9, minus 4 times 1 times negative 5. So 4 times 1 is 4, times negative 5 is negative 20. All over 2a, which is 2 times 1. So this would be negative 3 plus or minus the square root of 29, because minus a negative turns into a positive, over 2. So this intercept form would be x minus a negative, which would be plus 3 plus root 29 over 2, and x plus 3 minus root 29 over 2. Those are our answers. All right, now find the vertex. So to find the vertex, negative b over 2a is going to be, we can look at this, and this part right here is negative b over 2a. So that would be negative 3 halves. So if I plug in negative 3 halves, x of negative 3 halves, I have negative 3 halves squared plus 3 times negative 3 halves minus 5, or that's 9/4 minus, this is 9 halves minus 5. This would be 18/4. So 9/4 minus 18/4 minus 5. So this is negative 9/4 minus 5. 9/4 is 2 1/4. So this would be negative 7 1/4. So we have negative 1.5 and negative 7.25 to be my vertex. Hopefully I did my math right in there. All right. Now write a possible zero for a third degree polynomial that has zeros at negative 5, 2, and 3, and a y-intercept at 15. All right, so it's third degree, we have 3 zeros. So we have everything. Oh, I should tell you to pause it, do the problem. This one would give you x plus 5. This would be x minus 2. This would be x minus 3. And y equals some value times that. So if the y-intercept is at 15, if I plug in a 15 for y, then I don't know my a, but my x is 0. So 5 times negative 2 is negative 10. Negative 10 times negative 3 is negative 30. So I have negative 30a is equal to 15. Now when I divide that out, my a value is negative 1/2. So my equation is y equals negative 1/2 x plus 5, x minus 2, x minus 3. All right, let's try a new one. Write a possible fourth equation for a fourth degree polynomial that has zeros at 1 and 2, and a 0 with a multiplicity of 2 at negative 4. Pause the video. When you're done, press play. All right, we know that it's y equals a, x minus 1, x minus 2, x plus 4 squared. If I plug in a 0 and negative 64, I get negative 64 is equal to a. 0 minus 1 is negative 1. 0 minus 2 is negative 2. 0 plus 4 is 4 squared. So this would be 16, negative 32, positive 32. So I would have 32a equals negative 64. Divide by 2 and by 32, and we have a is equal to negative 2. So my equation is y equals negative 2, x minus 1, x minus 2, x plus 4 squared. All right, let's try another one. What is the degree of this polynomial? Hopefully you don't have to pause the video for too long. Degree equals 5. What is the degree of this polynomial? Well, if I expand this like the previous one, this would be x. That would give you an x squared, and this would be x to the third. So x times x squared times x to the third will be x to the sixth. And so we would have a degree of 6. Now name all the real zeros. This one would have a real 0 at -1. This one would have a real 0 at 4. This one would be a complex 0. Now since it's asked for real, I don't need to find it, but just in case I said find all the zeros, we would find it by solving for our value. And so it would be plus or minus I root 3 for the other two. But since it says find all the real zeros, that's all I'm looking for. So without using a calculator, write the following function as a product of its linear factors and sketch the graph using intercepts and leading coefficients. So pause it for a couple minutes and try to figure this out. All right, hopefully you're done with this problem. And so now what we want to do is solve for this. Now, I have no idea what the answer is, but I do know that the values can be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, no, not 4, not 5, but 6, 9, and 18. And it's a higher probability that the lower ones will work. So we plug these into synthetic division. And by the time you get here, you'll see that that's not going to make a 0. So 1 is not what we're looking for. Let's do -1. 1, -1, 1, -1, -10. That's not going to get us there. So let's try something bigger. Let's try a 2. So if we have 1, 2, 4, 8, -1, -2, and that's not going to work. So let's try -2, 1, -2, 0, 0, -9. Oh, look at that. We got 18, and that scratches out. So now this is x squared minus 9. So x squared minus 9 can factor into x plus 3, x minus 3. That -2 tells us that it's x plus 2. So we have our equation f of x equals x plus 2 times x plus 3 times x minus 3. That's written as linear factors. All three of these are linear equations. Now sketch a graph using the intercepts and leading coefficients. All right. Now we have 0 at -2, -3, and a +3. And they're all single zeros. And we have a y-intercept at -18. Let's just call this -18. So since it's a positive leading coefficient, it starts down here, comes up, passes through there, and shoots back up. And that is our equation. All right. Now, this is a new problem. Try to find this, f of 7, without using your calculator. All right, hopefully what you did is you put 7 in the box. So we have 1, 7, 3, 21, -1, -7, 2, 14, and 16. So now we know f of 7 equals 16. Now find all of the zeros in this function. All right, pause the video. Hopefully you're done with this one. Now since it's -12, we look for all the factors, plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Quite a bit, 24 different possibilities. I'll start with the smaller ones. 1, so it's 1, -3, -9, 23, and -12. And look at this. This would be fantastic if it worked right away. And it did. So we broke this down to x cubed. So now we can start again. And we didn't actually eliminate any more answers because we're down to 12. So let's try 1 again. So 1, 1, -1, -1, -12. Oh, look at how that was some good luck there. It um, worked out for 1 twice. So now I have x squared minus 1x minus 12, which is x minus 4, x plus 3. And we have x minus 1 squared. So this is written out. And so to find the zeros, we have positive 4, -3, and positive 1, and this one has a multiplicity of 2. All right, so let's draw the graph for that function. So pause the video for a second. I'm going to actually go back to the previous page to draw the graph. We have zeros at 1, 4, and -3. Our y-intercept is at -12. And it's a 4th degree polynomial that's positive, leading coefficient. So it's going to start from the top. It's going to come down. It's going to come up here. And that 1 is a double zero, so it's going to curve back around and then keep on going. All right, there is our polynomial function. Now, in this one, take a minute, fill out all of these values, and see if you can do this on your own. All right, your y-intercept is at 0, -35. Your vertex, -b over 2a, that's -2. That's 2 over 2a, which is 2. So that would be 1. If I plug 1 into my function, I have 1 squared, which is 1, minus 1 times 2, which is 2, minus 35. So that would be my -36. If I factored this, this would be x plus 5, x minus 7, and my x-intercepts would be at -5, 0, and 7, 0. All right, I think that's enough for one class period. And hopefully you understand this and you'll be ready for the test tomorrow. Good luck.